Instead, let's gather the moles in interplanetary space. Gravitational attraction pulls them together into a sphere. Meat, being mostly water, doesn't compress very well, so we end up with a mole planet that's a bit larger than the moon. The mole planet is larger than the moon, even though it weighs around half as much, since water is much less dense than rock, which you can demonstrate by throwing a rock into the water, or noticing that the ocean stays on top of the Earth's surface. The mole planet has surface gravity about 1/16 as strong as Earth's. That's similar to that of Pluto. Throughout the majority of the planet's interior, the pressure is over 100 megapascals, which is enough to kill all bacteria, leaving no microorganisms to devour the mole tissues. The mole bodies gradually break down into kerogen, a mush of organic matter, which would, if the planet were hotter, eventually form oil. Mole bodies form a literal fur coat, which insulates the interior of the planet and slows the loss of heat to space. Convection in the liquid interior means that plumes of hot meat and bubbles of trapped gases like methane, along with the air from the lungs of the poor deceased moles, periodically rise through the mole crust and erupt volcanically from the surface, a geyser of death blasting mole bodies free of the planet. I told you this would be gruesome. Eventually, after centuries or millennia of turmoil, the planet calms and cools enough that it begins to freeze all the way through. All told, this is a pretty bleak picture. Let's try an alternate approach. I don't have reliable numbers for the global mole population, but we'll take a shot in the dark and estimate that there are at least a few dozen mice, rats, voles, and other small mammals for every human on Earth. There might be 1 billion habitable planets in our galaxy. If we colonize them, we would certainly bring mice and rats with us. If just 1 in 100 were populated with small mammals in numbers similar to Earth's, after a few million years, not long in evolutionary time, the total number which had ever lived would surpass 6.022 times 10 to the 23rd.